So with this one, what we are going to do is today our project is based on how to run the setup. So what I'm going to tell this is to compile and upload. Let me see how best my AI, my wrapper will do. So it's going to upload this code onto my ESP32. Tell me I'll be in black screen. So now I'll wait for my AI. I'll wait for the AI to compile and upload the code onto my ESP32. Then what we'll do next is we'll go and connect all the connectors. We'll go and check all the connectors. So we are waiting for it to finish with the compiling before it uploads the code. So as it is compiling, we'll try to set it up so that we'll know the exact connection. So after it is done compiling, we'll tell the AI also to let us know where each pin is, and let's see if we'll be able to work it out with where each pin is. So the AI should be able to tell us where exactly each pin is and the component needed for it. So this is the code. So even with here we can know where each pin is. So today I'm having the MCP sensor. So these are the sensors that we are going to work out with. So I'm having the MCP472625 for each current and voltage sensor. And this one, we have to use the voltage out of pin, which is the analog to digital converter voltage out, and this one also will connect the 34 to the ACS device unit that we have. When I try to update these things, you are not going to go now, so I'll just go off from it. Then let's see how best we can work. So let me wait for it to finish. If not, then let me try and upload it. You can see no board is selected. Let me select my board. Should be on pin 15. Okay, let me see if I'll be able to connect it with pin 15. then I'll do the upload here. ESP32, ESP32. I don't know why the software opened it for me, so if it has opened it, then let me upload it using the. Then today we'll do our connections. We needed to wait for that long because I needed the sensors to be in, and these are the sensors that I'm talking about. So, and these are the sensors that I'm talking about. So these two sensors, one is for the current and one is for the voltage. One is for the current and one is for the voltage. So we are going to work around them. So now that it is connected, let me see, let me just upload it from here. So one thing I like about this is when you allow the AI to write the codes like this, what normally happens is the AI is able to, when it happens this way, the AI leaves comment for you to understand the code that it has written for you, so that you know what to do in case you are doing anything or when you are going around it. The AI helps you to identify other things. So with this one, let me just do upload. Because of the way I opened it, so what I'm going to do is, let me just stop this AI from. So I'll come back to this and add certain things. So anything which anything that I think is not okay with the code, I'll ask him to do it for me. But for now, let me, okay. Oh, wow, let me repeat my command. It looks like when I cancelled the AI from doing it, that's also closed the thing. So let me redo my command. Yeah, let me let it do it because I know it should use the Arduino CLI, because I have the CLI. I have the CLI on board. So let me see. If not, then I have to open the file and make. Let me open the file with my Arduino. If this AI is going to delay. because today you are not going to allow him to delay us like the last time we came online. So let me see. Okay, let me close this. Let me open it from here. Or should we try Gemini? We can try Gemini also. So let me open my command prompt and try Gemini. It has been a long while since I used Gemini. Let's say almost 2 to 3 weeks now since I used Gemini CLI. Wow, this T2 is delaying. Let's do the. Okay, let me do the 2 first. Then let me go. Okay, let me do Gemini. Okay. Whilst it is open, let me minimize it and check on my Arduino. Okay, it looks like my Gemini has an update. Wow. So let me try and copy this code. Let me copy this code. Copy. Paste. Let me click on enter. Let me see still. Why is it behaving this way today? So now I'm updating my Gemini. Then we are going to use the Gemini today and see how best we can go about it. So with this one we are going to do more of the wiring, so I'll bring you guys along with the wiring. So that means I have to put this one aside. So at long last my ID has opened. So let me see. Yeah, this one is a Gemini 2 that I want to upload. Yeah, so if you can see, we are using this one for current, one for voltage, and also when you go through it, you can see I'm using pin 21 and 22 as my SDA and SCL, which is I2C connection. And with this one also, let me bring you guys and also with this one, if you check it closely, you can see it has I2C connection on it before the voltage out. So we are going to connect the ground, the I2C, and the voltage out. Then we will check and see how best we can go around it. But for now, let me set it up. For now, we are going to wire the whole thing, which is this one. We are going to wire the whole thing, right? Then we can use the I2C connection that they are stating. Then also we do other connections, but you know our ESP32 has this. So the I2C, that's the same connection that this screen is using. So that's the same connection that this screen, the OLED, is using. So what I'm going to do is, that means I have to disconnect the OLED from the breakout box and connect everything here, so that all of them will share the same I2C connection and give all of them the same voltage that they need. The same voltage that they need. So these two are the ones that I'm going to work around it. So this is a load test. Let me put this thing here. Let me bring my cables. Then the other connection. So these are my cables. The major work for this project is the connection. That's what you are going to do. So the connection, that's what you are going to do. So let me bring on board the remaining sensors. So the most important thing is the connections. And I have this load resistors for testing load. One is 0.5 amps and the other one is 1 amp. That's the amount of current they can draw. So this one, let me move this from here. We are not going to use this today. We are not going to use this today. This is for AC. So let me check with my. Okay, so this is my pinout that I'll be using. So let me do the connection with the pinout. I'm hoping this time it works. So before I do that, let me do my compiling and uploading. Let me allow it to compile and upload this code onto it, and we are going to use the voltage divider for the we are going to use our voltage divider to read the voltage going into the voltage that our power supply will be giving out. So we'll use the voltage divider also to read that voltage. And this MOSFET gate, we are not going to use it for now because that's for controlling the fan. So we'll set up our encoder, then we'll set up our ADC1 and ADC2. Then we set up our DAC, and so the DAC is the digital analog converter and the ADC is the analog digital converter. So what it means is this sends digital signal, right? It sends digital signal into analog, and this one also converts analog signal into digital signal. So that's why they've given us the pins that we'll be using them. So this voltage out will be for our voltage divider that we'll be using. So with the voltage divider, sorry, I've not selected the board. That's why I've not been able to upload. Let me do this. ESP32 DV. I have not selected the board. That's why when I click on compile and upload, it's not working. So what I want to do now is I want to upload my first code and check it with after uploading. We'll do our wiring diagram. I'll prefer to draw the wiring diagram. That will make it a bit easier for me, or to give us a bit understanding. So you can use the AI to do the work, but the only problem is when it comes to the wiring, you have to figure a way to do it. So I'm using ESP32 DV module. That with my code, because I added Bluetooth signal to it, so you can see the Bluetooth serial to it. So I needed to downgrade my version of I needed to downgrade my version of the ESP32. So let me do my ESP32. So this is the board money, and my ESP32 is down. Okay, let me go to tool, let me select, and with here you can't see the version, right? With this one you can't see the version. This was should give you the version. Okay, so if you can see my ESP32, okay, let me upload the code and see. When the error comes in, then I'll do the downgrade. But it looks like my ESP32 has been updated. So because the last time when I was trying to update it, I was getting error with the Bluetooth serial. So with the Bluetooth serial that I was getting an error, it means I needed to downgrade my ESP32. I needed to downgrade the firmware of my ESP32. So now let's allow it to compile. After that, if it gives us any error, then I can downgrade it to any of the 2.0s. With them, that one it will work. So let me wait for it to finish, then let's go to our drawing board. Okay, let me minimize this board thing out first. So there's it. Let me bring this thing down a bit here. So there's our pinout. So let me pick a pen and let's do so let me do it first. This my ESP32, right? So where's the pin out that I'll be using? So don't mind the pin out there. So the pins that we'll be using on the ESP32 will be 22 and 21. Which pin again? 35 and 34. Then which pin again? 33, 32 and 27. Then which pin again? 26, 25. Okay, so with this pin we connect them to the breadboard. So I'll be connecting to 3. So I'll be connecting to 3 I2C devices. I'll be connecting to 3 I2C devices. So my 3 I2C devices will be here. And all of them will need power and ground. Okay, so my 3 I2C devices, this all goes to one line. So this J, this V, this SCL and SDA. So with the diagram it tells me LCL is 22, so LCL goes to 22 and LCA goes to this. So if I connect this one pin and the other pin and the power and ground. All of them will go to one sensor, which is here, which is MCP1. Let me name it that way, and let me do another square here, and MCP2, which we are going to use this for. It goes here, this goes here, this goes here, and this goes here. Then we are going to see my screen to be here. That's my OLED display. So my screen will have power, ground, and LD and LC. So this is how you are going to. So this is my ESP32. So that's my ESP32. So this is only for the connection. Now it's left with the encoder. So with the encoder, it also needs power and ground. So the encoder will have rotation clockwise and anti-clockwise, and click, and power and ground. So this will be my encoder. So let me connect this one. So this power to be shared here, and this ground will also be shared here. Then this will be going to the ESP32. 1, 2, then 3. So now I'm done with my encoder. Now the sensor which is left with is the voltage divider, and my voltage divider also needs power and ground and voltage out. So voltage divider, let's do it this way. So it needs only 3 pins, and let me show you how the voltage divider looks like. Okay, so I've started compiling. Some people call it voltage sensor. So normally this is how the voltage divider looks like. Yeah, this is how the voltage divider looks like. This measures up to 25 volts, and with this voltage divider you can see these 2 resistors. There are 2 resistors in there. So I'm going to measure the 2 resistors. Those resistors are the ones that if you check or if you run through the code, you can see them here, right? So these are the 2 resistors. So the thing is, the resistor, sorry, let me try and focus on it for you. So I have to measure the resistors and input them into the code. So the AI assumed, the whole thing is, I'm not the one who wrote the code. That one I will not lie, I'm not the one who wrote the code. So it's the AI commanded it, and it gave me the code that I need. So now I'm going to measure the resistance, then I'll input them here. And with that, we will need only the ground and the signal. We are not going to use the power. We will need only the ground and the signal. And from our pinout, it shows us that it is 35, right? 35. So I'm going to connect the sensor side to the 35 pin, or let's put it pin 35. So that's the pin 35, and this can be connected to any of the ground here. So I can choose if I give ground to this side, then I connect it. Then it will left with our sensor, one of the sensors which will be measuring the current sensor, which we call the ACS725. I think I have that one also here. So with that sensor, I have two types. Yes, here is the other one. No, this one is a voltage divider. So this is a voltage divider which you can use to measure voltages. And this my, yes, it's 2-1. It's 1-2 rather. So this is what will be measuring the current for us. So this is what is going to measure the current. So with this one, is going to convert analog signal into digital signal for the ESP32 or for the ESP32 to understand, or will be able to tell you what is really going on. So this one we will use all the cables. So we should have one power and one ground. So with this one we have one power and one ground. That's our, so if you check the name, that's the ACS712. So that will be the only one left for us to connect to. So now what I'll do is I'm going to try and connect that one also. So we have to do all these connections first. We have to do all these connections before we can get any access. So what I'll do now is, it's left with the, so with this one we are going to connect to power. So let's say if we are having our power here, or maybe our VIN and G. So I'm going to connect to ground on this side. So this should be G, this should be V, and this should be signal. So let me do it this way, move it this way, and join it to it. And because we are using the analog to analog, because we are using analog to digital conversion, so that one from our, we can see the pin to be pin 34. So let me connect pin 34 to this. Yeah, so we have pin 34, and I can connect my voltage here and connect it to this. So this is not connected, so I connect my voltage to this. Yes, so this is all the connection that we will need to do for the ESP32. So whilst we are waiting for it to do the for it to upload the code, what we can do now is, let me measure the voltages also. Let me measure the voltages also, and let me measure the resistance in the voltage divider. So this is my voltage divider. Let me measure the resistance in the voltage dividers so that we can be able to input it into the code. But for now, I have to let it finish uploading this code, and the reason why it's keeping long is it has to compile it first. So let me see, let me place it where you guys can see. Okay, let me just do it this way. No, this way. Yeah, this way is better. Okay, so let me bring my voltage divider. Where is it? Yeah. Yes, my voltage. So the voltage divider, you don't need the plus in it. You only need, with the voltage divider, you don't need the plus in it. You only need the X and the P. So if you can see properly, you only need the S and the P. So let me measure my first resistance. So let me, oh shit, sorry, my multimeter was not set to resistance. So let me say 30k, because it's around 29.99. Let me check my test leads first and make sure they are at 0. So now my test leads are well calibrated and they are at 0. So let me do it again, and 30. Okay, so 29.99. Let me say approximately 30k. Let me also measure the second resistor, and okay, so let me say approximately this one will be also 7.5k resistor. So 7.5k. So what I can do now is, now I know my voltage divider is around 7.5. Let me see what best can I do for myself. Okay, let me go to, so this for the AS sensor. So let me go here. This is what I'm searching for. So 10k, which is 10,000, and I have to do it. Let me change the value here. I have to do it 30. So delete 1, 2, 3. Then do it 3 Then let me come down to 1, 2, so it will be 7 and 5, so 7,500. Yes, so this is what it should be. And for this one, okay, sensing is let me read through and see what I can do about it. So for this one, let's try and let it finish what it is doing, then we can do our connection. So that means today I had another breadboard that I'll be using for this work. I'll not be using the breadboard over there. So this should be okay. Let me cancel this and recompile it again. I don't know why it's running that slow. So let me recompile it again and see. So we are going to start our wiring. So let me just place this somewhere here. Then after all this wiring, now the main problem is our power supply. The only wiring that I'm not going to do here is, you see, with our power supply, or sorry, the power supply that I'm going to use, right? It has this thing, this resistors that I have to remove. Yeah, so for the power supply that we are going to use, I have to remove these resistors, and some of the power supplies have two. So two, if it is two, then that means one will be for current. I want to show you the power supply, or let's say a buck converter, or a buck converter that I want to use. So I have to use one buck converter and one boost converter. So this is just for the buck converter. No, this flow. This is just for a buck converter or a boost converter that I want to use. Then later I'll find for a buck converter also and use it. Oh, I had this buck converter here. So this is the kind of buck converter that when you are using, you will need two of this. So these sensors, what they do is they convert digital to analog, right? And these are analog. So these buck converters, when you are changing these are resistors, these two are resistors. So the moment you are changing the resistance, then it will be affecting what we call it will be affecting the voltage. So if it is 5 volts, okay, let me do this now. Now that we are waiting for it to compile, let me do this. We are just waiting for our software to compile. So you have to understand what you are using and what you are doing. So let me place my multimeter somewhere you guys can see. So if you can see, oh, sorry, the light is too much. So let me measure the resistance, and this resistance is for the two side, and I'm measuring almost 800, 0.800. You can see the point in front of it, so which is almost not even up to 1k ohms. So it's not even up to 1k ohms, right? So it changes the voltages. So you can see I'm measuring 1k here. Sorry, I'm measuring 0.1 ohm is even 0. So I think the reason why it's 0, when you check the, I don't know how to show it to you guys, but when you check, it looks like they've joined this pin and this pin together. So that will be for the voltage, right? So if I'm measuring 0.8k, I should measure the same 0.8k. So now what I'm going to do is I'm going to try and measure and turn it. So this is an analog, so the resistor reduces the voltage, and the processor which switches the voltages also knows the amount of voltage to give out. So the work of this will be done with this PMP, will be done with this MCPs. So let me measure this one, the second one. So one is for voltage, one is for current. So let me measure the second one. The second one is around 4.26 kilo ohms. Let me measure side by side, which means it is almost 10 kilo ohms, right? So 10 kilo ohms. Let me tune it a bit and measure it again. I'm having only two hands and I can't hold it and tune it, so let me tune this a bit and bring you guys back. Let me tune it a bit and bring you guys back. Yeah, it is tuned a bit. So let me see. So you see, the moment I tune it, now I've tuned it to 2.79 kilo ohms, and you can see it's increasing, right? So with this one I need only 2 wires, but with this one I need almost 3 wires, because whilst this side is reducing, this side is increasing, and if this side is decreasing, this side will be increasing. Let me tune it to the other side also and see. But with this voltage one there, it is constant, they go one way. Okay, so now let me measure it again. Yeah, and you can see now I've gone to 5, and this one should be around 4. Yeah, so that's all. So if this one also, let me see this one. So that means this one is 10k ohm resistor, and this one should be, let me turn it for a while and see. So now let me check it. So you can see I'm having 1.5, 1.6. Sorry, I'm having 4 point something. So it's around 4.7, 4.6. It's the same thing when I check it here. And to cement our search, let me switch it to voltage and let me power it up. So let me power it up. This voltage in, voltage out. Let me take the voltage out, cables out, so that it doesn't short anywhere, and let me plug in the voltage in. So I'm coming to feed it with voltage. Then you don't need that resistance. I remember the last time I blew one of my buck converters, I didn't check the pin properly, so green goes to positive. Let me do that and bring it. So we are waiting for it to compile, then we'll be able to use it. So this is the concept about the power supply thing that we are doing. So now if you can see, it has turned on. Yeah, this means it has turned on. So let me do this thing this way. Let me turn it this way. I'm using a very rigid cable. So let me measure the voltages. So first let me measure the output voltage. So with the output voltage, it is around 14.19. 14.91. So let me measure this, and you can see I'm having 13, right? So this is the voltage. That when you tune, it starts to change, right? And I think this is the current. So when you check both sides, I'm having 304 millivolts. So let me do this, and you can see I'm having 11 millivolts. This is the current, the one for tuning current, and this is the one for tuning voltages. So the resistance will reduce the voltage, but my output voltage itself is around 14 volts. So do you get how these buck converters work? So with that understanding, let's continue our build. Let me put this one somewhere here so that we can be able to build it. So now the main problem is these things that we are going to build. So let me see. So let me see, because I'll be, so I need a jumper pin to pin, but before that let me do my pin. Brown power, because both of them will be using the same power, and this one I'm going to use boom 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 boom. So this is the one that will be going, this is the one that will be going from the ESP32. This compiling has taken much time, and I don't know why it's taking that much time to compile. So now I'm done with it too. So my next should be, I have to get these pins. So black to white to SL, black to, okay. So let me do this also here, white to SL and black to SL. So with this one, it's going to help me to do the connection, although I'm not doing the voltage in, you can see G in and G out. I'm not doing them now. I'm only trying to see if my device will be able to communicate with them. So now that I'm done, that means my ground, everything should be picked from one side. And let me disconnect my power also, my screen also. So where should I place the screen? Should it be here? Okay. So now that I've started my wiring, let me see if I'll find another set. Yeah, this is my encoder. So with my encoder, I can leave it this way and just connect it to it. So let me go to my box that I have my cables in. So now let me see how best so for let me connect this for. So which one is ground? Which one is VCC? Ground and VCC, right? So blue and green. Ground and VCC. So let me do ground. It's number 1. VCC number 2. And CL is the same as the CK. Some of them you might see CK. Don't worry. So see. Okay, so now I've connected this one. So what I'll need is to connect my power, my CL and CK. So now let me use this, which I have to get 4. Okay, so use ground. I can use the 5 volt, I can use 4 volt, but this one is ground. No, this one is VCC. CL and last one. CK. Oh, hoping this thing will be able to compile as quickly as it can. So now let me see. Yeah. So now that's how I'm going to connect it. Which one is CD? So I have on my D2. Let me see. Let me go down a bit on my. Let me go down on this. Okay. So let me check my 22 is CL. So I'm having 22 CL and 20. One. Then this ground. VCC. Okay, it's working now. So now my screen turns on. That tells me that it's working now. So it's left with my encoder. Where is it? Yeah, so this is what I'll use to select my menu. This is what I'll use to select my menu. So now let me do that one also. So I have my ground, my VCC, and so I can do that selection from here. So ground, then what I'm going to do is with this one, because I've already connected it here, so I'll search for the pin which is 34 and make sure it is plugged on 34. Let me see if there is no conflict. Yeah, there is no conflict. So it's 34. Okay, so now with this one, I'm done with the connection. I'm done with the connection for the ACS712. Then let me move to the next one. I have wrongly connected something, right? Yeah. So now let me take my ground, my black and red out. Let me see. And then let me go to 5. Then CLK is orange. CLK is at what number? 32. So 33 from 35, 32. And CLK is the click and DT is white. So DT is at what number? 33. The white should be at 33. After 32, 33 is the next thing. Then 27 is switch. So I think the pressing one, right? Clock and clockwise. So the CLK is the clockwise. So 27. So 1, 2, 3, 4. 1, 2, 3, 4. The fourth one. So now I have connected almost all my sensors. It's left with only one sensor that I have not connected, and hopefully that's my voltage divider. Yes, so the voltage divider, I'll connect only 2 pins. So I'll connect the ground and the S. Let me change this so that it doesn't cost anything, but I just want to change it. So with this one, what is the pin out? 35, right? So 35 should be next to 34, which is red. So that's my after 34, then 35. So then I can use the ground, which is G, on this board. So G. So now all my sensors are connected successfully. Yes, now that all my sensors are connected successfully, what I can do is to wait for it to compile. The only problem I'll be having is now I've done all my connections. So with this one, I can connect to any of my devices to find the voltage. Let me keep my wires organized. I'm too disorganized. Let me put some of my wires for me. So now I'm waiting for the code to run. Okay, they are the same thing. I'm just switching it to this one. So I'm still waiting for it to. So after it is done, if I'm having any issue with my ESP, the next thing I think I'll do is I'll connect my INA219 also to it. So you have to buy all these things for you to be able to connect with this. So this is also a voltage, but this measures up to 32, up to 3.2 amps, which is this. So let me try and see if you guys could get a view of it. Oh, sorry guys. Yeah, so if you can see the name, but just that it measures up to 3.2 amps, and that's very small for the kind of power supply that I'm building. So now that I have all my wires connected successfully, so I have to, there is a prototype that I'm running. So if I'm able to run this successfully, the next thing I'll do is I have to find a way of inputting all of them onto something like this. I have to do my wiring on a board like this. Yes, maybe I have to use like 2 or 3 of these so that all of them can connect. But the most important thing is the software. The software is the most important thing. So you getting it to run, doing the wiring, it might be difficult for someone, it might not be difficult for others, but the most important thing is to get it running. That is the most important thing. If not, you will not be able to get it. It will not work with you. So I think yeah, still waiting for it to compile, and after some hours I have to go to bed. When we wait for about 10 to 15 minutes, I have to let it compile by itself. Then from there I'll know what to do, because at least it has to compile so that we'll be able to run the code the last time the same thing. I don't know why it's running this slow. I don't know if it's for my PC or something. So even if it's able to compile this code, we'll run. So let's go through the code whilst it is trying to compile it. So I also told the AI to use the free RTOS and the state for management. So if you can see, it tells you a lot about it. So it gives you the UI, and this structure holds all the data shared between the two core. So I also told the AI to make use of the 2 core, because the ESP32 is a dual core CPU. So I told the AI to make good use of the dual core system of the CPU. So that's why it's telling you that it shares data between them. And these are voltage and these are current, and you can set the current and you can set the voltage, or it also measures the voltage and the current. So with this one, the reason why we have the thermistor in it is because you have to add an input fan to cool the system in case it is drawing in more current, so you need an input. So the MOSFET gateway drive enables the voltage out so that the fan can be able to turn on. So instead of using a relay, you use a MOSFET gate drive, which will allow it to cool. So let's start from here. So constant floats with the analog digital conversion reference of 3.3. I'm not going to explain all these codes to you because it is self-explanatory. The AI does it, and you can see I changed the resistance because I measured it and I got 30. That's why I've changed the resistance. But when the AI did it, the AI wrote 100k and 15k ohm resistor, and it will mathematically work it out and give you the output voltage. So you can be changing these two values till you get the raw one, but there are other. So let's say if I go to examples, and I've downloaded the drivers for it. What is the name? Is it a voltage divider? They have a name for it. I'm trying to see if I can record the name. I wish I can record the name. Then you see an example of a code for the voltage divider. They have a name on it. Is it I'm hoping I remember the name. Oh, I wish I can remember this name. I wish I can remember this name. This I can. I have a lot of libraries because of the projects that I have now, and I'm hoping we'll be able to go through each project. And most of my projects I did them with the AI. So if you come to my file, you can see I have a lot of projects down that I'll be going through later with you guys. For most of my projects, I just wrote them down, but I've not, and after writing them down, I compile them to make sure they are working. Okay, so so I can open this whilst this is compiling. I can open it for you guys just to see. I wanted to see one that I wrote for the voltage divider. Yeah, voltage measure. So you can use your ESP32 for measuring voltages. So depending. So I want to show you the other way. Sometimes they will not ask you about the resistance of your voltage divider, but they will ask you a different question altogether. So I wanted to show you how it looks like on this one also. Yeah, it has opened. Yeah. So if you take this a simple code, let me see, because I'm using the screen, so let me see. So because it's an analog, is it analog to digital signal? So if you can see, it says analog to digital signal, digital signal, and it's making use of the 32 bits, and reference voltage is 3.3 volts. So if you know your reference voltage is not 3.3 volts, you just have to. So after the mass, if you can see, with this constant float voltage divider ratio, you just be changing it so you get the right voltage that you are measuring, and it has to match with your multimeter. So you can see adjust based on resistors. So that means the resistors on it. So if you can check this code is already having the resistors. So instead of it telling you to adjust based on the resistors, it does this math for you. So this is the math that it does for you, so that it can be able to give you the outcome. If I'm not getting the right outcome, I can do it 29,000 and do this 7,400 or 7,300 till I get the right outcome, like this. So this were the values that you will be changing till you get the right voltage that your multimeter is measuring, to measure it exactly this. So with this one, analog to digital, so there is the digital signal, and the analog signal will be from your voltage divider, and you have to make sure your voltage divider is not outputting 5 volts. The reason why I'm saying that is ESP32 input voltage cannot be above 3.3, else you blow the CPU or the ESP32. So this is an example of a code that I asked the AI to write for me. Now everyone is going AI, so you also have to know how to use it. So now I'm hoping this compiling does quickly, so that I will be able to go through the projects again and see. So we are still waiting for the code to compile. I'm hoping this should be able to compile quickly. Let me close this whilst I'm not using it. So let's go through the code once, because I don't know why it's still delaying, and the AI has also so hardware and calibration for us. So when you go through the code, you can see hardware and calibration. So let's say we are done with it. It will left with only the sensor, which we have to change. It says the sensor in voltage per amp, so 100 millivolts is equals to 1 amp. That's what it means. So for 20 amps, right, for 20 amps, that means you have to multiply this, or you have to do the division. So let's say for 20 amps it will be equal to 20 divided by 100 milliamps. That is going to give you, so that's 0.1 divided by 20. Let me see if my mass is good. Calculate that. That's almost 2 point something volts, right? So 20 divided by 0.1. Let's finish 0.100 milliamps. So 200. Hey, sorry. It should rather be multiply. So 20, because that's it. Let's see. It's approximately 2 volts. So I'm getting 2 volts right here. So you can see it's equal to 0.100, and it says the scaling is, so 0 volt should be around, default 0 current voltage should be around 2. So you use, if the output is divided by ADC circuit. Okay, sorry. Linear mapping coefficients. This calculation beyond, so constant current, constant voltage to the max. So 100 core 1, and this one 100 core 2, and multiplies the potential area. Global instance of sharing states. I'm hoping